So this is chapter 6C on angles in parallel lines. So we will talk about the facts of angles on parallel and intersecting lines, and then we will be doing some problems. So here's some facts. Number 1, perpendicular lines meet at a right angle. So when you have a horizontal and a vertical line, cross, it creates a 90-degree angle, and that is what you call a perpendicular line, because these are two lines that cross to make a right angle. Parallel lines are always the same distance apart, so if you notice, they run alongside each other, and they never, ever cross. So think about ladders, think about train tracks, they just never cross. Now, these are very important to remember: vertically opposite angles, corresponding angles, and alternate angles. Now, vertically opposite angles, meaning angles that are across from each other when the letter X is made, so the orange and the orange, are equal, just as much as the green and the green are. So for example, if this orange angle was 40 degrees, so with this orange angle, and so with that orange angle, and so with this orange angle. And the reason is because you have two parallel lines, so they're keeping the same distance the entire time, and you have this one line that crosses them. And so therefore, when they create the letter X, the angle just opposite of it will be equal to each other. And since this line is basically the same line as this one, it's going to be the same because they're parallel lines and they're being crossed by the same one line. Now, corresponding angles create an F shape. So if you look at the two parallel lines here and how the line crosses through between the two parallel lines, right here is the letter F. And underneath the letter F is this green angle, which means that those are corresponding angles, because basically it's an angle on the line that's in the same location as the opposite parallel line. Those are called corresponding angles. Sometimes you can even see it as a backwards F. So here's a backwards F. So this angle underneath is corresponding to this one, meaning they have to be the same. But you could also say that the one above it is also the same, because those are corresponding angles. So as long as they're located on the same location of the line above and below, then they're going to be corresponding. Now, alternate angles create the letter Z on these two parallel lines. So here's a parallel line, here's a parallel line, here's the line that crosses. The Z shape, if I color this in really strongly, where the lines make the zigzag right here, those are called alternate angles. Now, of course, you could also see this as a backwards S. So I can also do this, or a backwards Z. So meaning this part of the crease is the same as this part of the crease. That is, those are alternate angles. They're the same. So you can also argue that on the other side of it, right here, is going to be the same to each other. Those are alternate angles. Those are actually a Z shape. So as long as you see a Z or like a S, those and an angle inside, those are alternate angles. So those rules are very important because now you're going to apply them to solve for missing angles on parallel lines. In problem A, it's this very straightforward one. You have a parallel line and a line that intersects them, just like we did in the previous slide. Now, however, at problem B, it's a bit tricky. And how we know lines are parallel is because they have these little arrows on them to indicate that those two lines are parallel. So anytime you see that That's a big hint to you. Those lines are parallel. So you had to use the rules in B of parallel lines and also rules about triangles to solve for the missing angles. So at this time, pause and give it a shot. Okay, so in problem A, and just to let you know, there's multiple ways to approach these, and I'm just showing one way. However, if you've come up with another way, you can check in with your teacher just to make sure it's okay. Now, I can see that this is a backwards F. If this is 140 degrees, that means this one right here is also 140 degrees because those are corresponding angles. Now, I can see that because there's an X here, since A is completely opposite of B, B is 140 degrees because A and B are vertically opposite angles. Problem B. So problem is, where do you start? And I bet you might have started with A. Now, did you know that sometimes you don't have to start with the letter A? In fact, you can work from the letter C or from the letter B, or even, get it, work from an angle that doesn't even exist, that's not listed. So for example, I see this triangle. So I notice that this is 90 degrees. I notice that this is 60 degrees. So if this is 90 and that's 60 and a triangle is 180 degrees, that means this missing angle right here has to be 30. Well, I notice that this is a straight line. I can ignore all this and notice that 30 plus angle C has to make 180. Therefore, angle C has to be 150 degrees because together they make 180. Now that I know that these two angles right here, 30 and 150, I can pretend that triangle doesn't exist and just really focus on the lines. I have one parallel line here and another parallel line here. I'm going to go ahead and extend this line right here so I can try to ignore the fact that that yellow-orange triangle exists and I can just focus on those parallel lines. If you just focus on those parallel lines, you'll notice that this angle right here is 30 degrees because you found it. You'll notice this angle right here is 150 degrees because you found it. And you'll notice, hey, B sits inside one of those parallel lines. Oh, that has to be 30. And the reason why is because these are alternate angles. Now finally, you know this is 30 degrees. We know that this one right here to here is 90 degrees because it's a right angle. And if you notice, this whole thing sits on a straight line. So angle B, this right angle, and angle A have to add up to 180 degrees. So 90 plus 30 make 120. To find A, this is 180 degrees, take away 120, which leaves us with 60 degrees. So A equals 60 degrees. So that was a bit of a complicated problem, but again, there's no real one right way to start. You can start from A, you can start from B, but make sure that you are using information from the problem by taking a step back and just looking at it. And that's it.